than x plus 1. So there's this 5 absolute value. Here's where my x is. I replace x plus 1. Minus 2, close the absolute value, plus 1. Same question I've asked before. Are the parentheses doing anything? No, so I get rid of them. 5 absolute value, x plus 1 minus 2, close the absolute value, plus 1. Can I simplify inside the absolute value?
Yes.
Yeah, I got like terms. 1 minus 2. Negative 1. X minus 1. Can I simplify anything outside the absolute value? Can I distribute into the absolute value? No, that's the answer. The next problem is f of x plus 1 as well. I'll zoom in a little bit. Sorry, I didn't realize just how zoomed out I was. The difference there is the plus 1 is on the outside. When the plus 1 is on the outside, it's telling you to take the function and add 1 to it, which means it's telling me to take my 5 absolute value. It's still of x, so I'm just going to leave it as x, minus 2, plus 1, and it's telling me to add 1 to it. This part right here was all just the original f of x. This was the original f of x function. That's this piece. And it said to add 1 to it. Can I simplify any of that? The two ones could go together. 5 absolute value x minus 2 plus 2. That's it. That's all I can do. The last one on our warm-up, 3f of x. What's hiding between the 3 and the f of x? Multiplication. So it's saying to do 3 times f of x. Now f of x is a big long function. And it wants to multiply by the entire big long function. How do I know it's multiplying by the entire thing? Because 3 is multiplied by all of f of x. That's what that means. Which means when I multiply it by it, I need this. I need parentheses. What do you do when there's a number in front of a parenthesis?
You distribute.
You distribute. Now, we already talked about distribution today. Can we distribute into an absolute value?
No.
No, but can you distribute in front of one? Yes. You can distribute this 3 to the number in front of the absolute value. Three times 5? 15. The absolute value itself does not get distributed into. The 15 here will take care of the fact that something's getting multiplied by x minus 2, both the 3 and the 5. And then this gets distributed over here as well. That is 3 times f of x. Now, the reason I did this today is because as we are moving into doing more with transformations today, we need to get to the point where we don't need the calculator to kind of see what's going on. Now, I already went a little bit deeper into 1.1 than I probably should have. I dabbled into 1.2 when we went through the 1.1 notes. So a lot of what we do today is going to look familiar. It's just going to be a little more formalized. So that warm-up is a part of your notes. I don't want it turned in. It is just meant to get us ready for our notes today. If you are a person who likes putting titles on things, today we're going through 1.2. It's our first day of it. We're going to talk about it again tomorrow, and it's transformations. And it's going to be on both linear and absolute value functions. So, today we're going to do a little bit more formalizing of what it looks like when we do transformations. To transform a function, say you're given f of x and you want to change it into g of x by doing these transformations on it. Generally speaking, instead of having just f of x, the transformed version, which they generally do g of x for the transformed version for no particular reason, what they do with it is they multiply numbers by it. Those are often considered an a. Both on the front of it, kind of like the last problem in our warm-up, or sometimes they'll do it inside the parentheses. Now, I don't know why they put a in both places instead of changing its letters. They just do. Those aren't the same. I know it gets confusing. We'll talk about it a little bit more. And then they subtract and add things both inside and outside the parentheses. This is kind of a more generalized format of transformations. Now, transformations come in a lot of different forms. We got our translations. Do y'all remember what translations do to a graph? Moves it around. I don't know why I called that movement on the second one, but that works. So, translations move it up, down, left, or right. So, up, down, left, or right. Now, as I go through and I talk about these, we are going to have transformations that happen to basic parent functions and transformations that happen to functions that aren't the parent function. So I'm going to do an example where I have f of x being just a basic absolute value of x. And I'm going to move it by 4. But I'm also going to have an example where f of x is more complicated. It's 3 absolute value of x plus 1 plus 2. I'm also going to move this one 4. Can you read that? Now, moving up, down, left, and right. To our equation, are we multiplying things by it? Are we putting negatives in front, or are we adding and subtracting things? You remember? For translations, you're adding and subtracting. If you want to move it up, in the generalized format, K is kind of the up and down movement. So if you want to move it up, you take your function f of x and you are going to add a k value. On the other hand, if you want to move it down, you subtract a k value. You want to move it left and right? Those are where the h comes in. So it's inside the parentheses for those. Left is adding. Oops, not k, h. Right is subtracting. So, if I want to move it forward, specifically upwards, it just says take the function, add 4. So, f of x being absolute value of x, and I add 4. Actually, don't write that part, just that. All I'm going to do if I want to move it up. If I want to move it down, same thing. Take the original function, subtract 4 from it. Now when it's the parent function, it's pretty easy to see those things. When it's not the parent function, it becomes a little more complicated. Because my original function was now 3 absolute value of x plus 1 plus 2, and now I'm adding 4 to it. And I simplify it, if possible. This is similar to the 4th problem in our warm-up. We just added something to the very end. Can I simplify any of that? What gets simplified? 2 plus 4. Everything else stayed the same. Becomes a plus 6. What if instead I want to move it down 4? I take the function and I subtract 4 from it. The original function was this 3 absolute value x plus 1 plus 2, and I subtract 4 from it. Combine my like terms. That's that 2 and that 4 again, but this time it's a positive 2 and a negative 4. Which becomes negative 2. If I want to move something left, it says to do x plus h in parentheses. So when you want to move something either left or right, same idea, you only do the adding and subtracting directly where the x is. So in a parent, in a parent function, when I'm trying to move left 4, the parent function, x, left means to add. I add 4 directly inside the absolute value because the absolute value is kind of like a parenthesis. It's a grouping. If I want to move to the right, absolute value x minus 4. But when it's a modified function, like this one, I have to be careful of where I put my plus and my minus 4 and what I can simplify. It goes directly next to the x. So the 3 didn't get touched. Absolute value. Instead of x, I'm writing x plus 4 in its place. And then there's still the plus 1 that was already there. Now in all technicality, this x plus 4 should be in parentheses. But is it doing anything to be in parentheses? No. So could I skip to writing it without it? Yes. And if I wrote it without it, could I have simplified any of this? Yes, what would go together? The 1 and the 4, making 5. The The 3 wouldn't have changed, the plus 2 wouldn't have changed. Same idea if I'm moving to the right, but instead of x plus 4, it's minus 4. Are you okay if I write it without the parentheses? Still got the plus 1, still got the plus 2, and I combine what I can, which is the negative 4 and the 1. Translations aren't generally terrible because of the fact that it's just adding and adding and subtracting doesn't tend to cause big issues. It's when we get to some of the other transformations that things become a bit harder. We've also got reflections. Now, we've talked about our reflections too, and the reflections also aren't bad. When you reflect across a specific axis. So instead of movement, this one flips across. And similar to before, I'm going to have just a basic absolute value function getting flipped. And I'm going to have the more complicated one getting flipped. And I'm going to stick with the same more complicated one. Now, reflections, the changes that happen in the equations for reflections are negatives go on things. You could put the negative in front of the function, or you can put the negative in front of the x inside the function. If it's in front of the function, it's going to flip across the x-axis. In other words, it's going to change vertically, up and down. If you put it in front of the x, it's flipping across the y-axis, and you'll notice a change left and right. I take a basic absolute value function. I put a negative in front of it. It looks like this. Ta-da. I know, it's a big change. I put a negative in front of the x. It looks like this. I know. Another ta-da. Big change. The more complicated the function can cause issues, though. Because as the function gets more complicated, the negative is in front of the entirety of f of x. Which means when I put the negative in front of this, it needs parentheses. Now, a negative in front of a set of parentheses is a -1 in front of a set of parentheses. What do you do when there's a number directly in front of parentheses? Distribute. Can I distribute into absolute value?
No.
Can I distribute in front of absolute value?
Yes.
Yes. Which means that negative goes on both the 3 and the 2 that were originally there. And it becomes this. Now, if I put the negative directly in front of the x, it's essentially putting negative x in the place of where x was. That's what that notation tells me to do, is to do this. Are those parentheses doing anything, though? No, so could I have just written negative x plus 1 in the absolute value? Yeah. If you leave it like this, I'm not going to hold it against you. But more traditionally, you would see it without the parentheses. And nothing would simplify.
There was, you put a negative sign.
I don't know what you're talking about. That's clearly not there at all. You see nothing. It was never there. Ignore the fact that the paper changed colors from yellow to white randomly there. Don't put a negative in front of this 3 on the second one. It's a mistake. Okay. The dilations is where the biggest challenge comes in. The dilations deal with A. There are 4 types of dilations. We've so far talked about 2 of them. We're actually going to add 2 more of them today. A dilation is a stretch or a shrink. Now, when you look at the basicness of what they tell you to do for a dilation, the functions themselves don't seem like there's 4 different versions. It looks like 2 versions, a times f of x and f of a times x. The difference is if a is bigger than 1 or between 0 and 1. When you're doing dilations, you ignore the negatives. You ignore the negatives because the negative aspect is just a reflection. If you see a negative getting put in front of something, a reflection occurred, not part of the dilation. You just look at the value of the digit for A. So if there was a negative 5 in front of something, the negative's a reflection, the 5 is the dilation. So, you can have the situations where A is bigger than 1, or where A is between 0 and 1 for each of these. Now the top 2, where A gets multiplied outside, we've talked about those ones already. Those are the vertical stretch and the vertical shrink. If A is bigger than 1, it's a vertical stretch factor A. If A is between 0 and 1, in other words, smaller than 1, but not negative, it's a vertical shrink. And the factor is also whatever that number is that you multiplied by, A. The horizontal stretch and shrink are backwards to what we would think. If A is bigger than 1, it is considered a horizontal shrink. The reason being is it goes back to shrink and stretch, based on the factor. And the factor for horizontal is the reciprocal of the number. It's the flipped version. If it was a 5 in front of the x, since 5 is bigger than 1, it would be a horizontal shrink factor. The reciprocal of 5 is 1/5. If the number is between 0 and 1, inside next to the x, it is a horizontal stretch. Again, the factor is the reciprocal. Now this gets easier to explain once you see examples. Right now I'm talking in words. It gets easier once you see what's going on. So, for stretch and shrink, A has to be either 3 or 1/3. It's going to vary a little bit depending upon the problem. Can I fit all of this on there? With this zoom, or do I have to change the zoom? I have to change it a tiny bit. Okay. So, starting off with our first one with our parent. I'm going to do the parent functions first, and then we'll move to these ones. This one, A, has got to be bigger than 1. In other words, we're going to work with A as 3 here. For a vertical stretch, that A gets multiplied by the entire function. If the entire function is the parent function, then you just put a 3 in front of everything. That is what a vertical stretch will look like. A vertical shrink, A has got to be between 0 and 1, so that's when it's the 1/3 that you'll see in the problem. Now, if A is inside the absolute value, or inside the parentheses if there's parentheses, bigger than 1 is a horizontal shrink. So the absolute value of 3x is a horizontal shrink with a factor of 1/3, because that's the reciprocal of 3. Remember, a reciprocal, you flip the fraction. 3 is traditionally 3 over 1. Flip it, the 1 goes on top, the 3 ends up on bottom, 1/3. Well, when it comes to vertical, the factor was whatever the numbers were. For horizontal, the factor is always flipped. If A is 1/3, in other words, I have this going on, the factor in the problem is 3, and it's a stretch, because the factor is kind of how you know it's a stretch. Stretch, you generally think bigger, the factor is bigger, even though in the equation it's a smaller number. If I do it to an entire function that's modified like this one, much like on the flip over the x-axis, vertical stretch and shrink have to go in, get multiplied by everything. That's what this notation says. A gets multiplied by everything. A gets multiplied by everything. So when I put the 3 in front of this entire thing, I'm putting it in front of a set of parentheses. And much like before, I should have given myself more room. I should have made this one 2 lines. My bad if you're writing kind of small. Much like before, number in front of parentheses, we are going to distribute. 9. Absolute value x plus 1 does not change, but the plus 2 becomes plus 6. Again, I'm sorry, I needed to give more room for this. It's hard to read. If you're not sure what I'm writing, please let me know. Vertical shrink, I put the 1/3 in front. 1/3 times 3 is 1. 1/3 times 2 is 2/3. The vertical stretch and shrink on a bigger function you have to distribute, and it becomes a pain in the butt sometimes. Sorry, don't mind me. Horizontal stretch and shrink. Thankfully, those happen directly next to the x. Again, a horizontal shrink if a is bigger than 1. So all of a sudden it becomes a 3x plus 1 inside the absolute value. Or for a horizontal stretch, it's a 1/3 x plus 1 inside the absolute value. Now that is a lot of information. This is the key to kind of what we are doing. It's the key that kind of changes all the things we're looking at. Today, and I only have a couple of examples to show you today because for the most part what we're doing today is very similar to certain things we've already done. You're going to see single transformations happening. Going to say write a function g whose graph represents the indicated transformations. On F. It will follow it up by giving you a function f of x and what it wants you to do to it. If you want to move a function up, what are you going to do to the function? Add inside parentheses or outside? Outside parentheses. Now, if you're wondering where the parentheses would have been in this problem, had we said inside, they would have been here. They're not there. And it says to do it outside. So I take my 3x and I add 5. I simplify if I can. Can I simplify that? No, that's g of x. Ta-da. Done. Final example. They're going to give you an f of x. 4x plus 2. They want you to perform a horizontal stretch on it. Stretches and shrinks. Are you adding and subtracting, putting negatives, or multiplying? Multiplying. Now horizontal, is that inside or outside? Inside. Horizontal is inside, so we're multiplying inside. But if it's a horizontal stretch or shrink, the number multiplied inside and the factor are? Reciprocated. They're reciprocals. What's the reciprocal of 2? 1 over 2. So I need to put a 1 over 2 inside parentheses. Do you see parentheses? The parentheses are where the x is if there aren't any. If you don't see any parentheses or absolute values, they're just around the x. Because essentially what this is telling us to do is f of 1/2 x. Replace x with 1/2 x in parentheses. Can I simplify 4 times 1/2 x plus 2? Do we generally leave 4 times 1/2 x?
No.
What's 4 times 1/2 x?
2x.
2x. That's your function g of x. Now a lot of explanation, but how do we feel about just doing the single thing to it?
Yeah.
Okay? Okay. Would you be upset if I moved today's connection stuff to tomorrow?
Yes.
You would be upset? That sucks. I'm done talking for today. I talk too much. Tomorrow is going to be a significantly shorter explanation of some things. Tomorrow there is a mini quiz. Tomorrow stuff is not on said mini quiz. Tomorrow there is not a new homework assignment. It's building off of today's homework assignment. The end of today's homework assignment is kind of covering the little bit that we're talking about tomorrow.